Alright, today we're going to be discussing latent heat. Up until this point, we've been discussing specific heat, which was the amount of energy necessary to raise the temperature of 1 gram of, for example, water, or 1 degree Kelvin, or 1 degree Celsius. Latent heat doesn't deal with raising the temperature. What latent heat does is specifically talks about the amount of energy necessary to change state of an object. For example, the first one we'll talk about here is heat of fusion. This is when something would go from a liquid to a solid, or vice versa. It could go from a solid to a liquid. But it's the amount of heat that's necessary to change this state, from one state to the other. If you're going from a liquid to a solid, then energy or heat is being given off. Heat is given off, and as things cool, it loses heat. If it's going from a solid to a liquid, then heat is coming in. And so what we're talking about here is it takes a certain amount of energy to change from a liquid to a solid, or from a solid to a liquid. The next one then is vaporization, and this one is when you're going from a liquid to a gas, or you're going from a gas to a liquid. Again, we're not talking about the changing of a temperature. There's no temperature change during these latent heat periods. What there is a change of state. And if you're going from a liquid to a gas, we have heat going in at the rate of 2,260 joules per gram. And every 2,260 joules, you'd have 1 gram of water that changed from a liquid to a gas. If you're going the other way, from a gas to a liquid, heat would be escaping. And for every 2,260 joules of heat that was escaped or has escaped, you'll have 1 gram of vapor, gas, that turns into a liquid. Now there's all of these states are on this graph, and what I want you to understand is this is a graph of maybe a beaker of water that's over a flame, over a Bunsen burner. And there's a couple periods on here where we're talking about specific heat. This part of the graph and this part of the graph is a change in temperature, so that right there would be specific heat. This one right here is a change in temperature, so that would be specific heat. But from here, notice it's at 0 degrees Celsius, and for a certain amount of time, it stays at 0. Well, what is this? This is fusion. The water is gaining energy, because it's still got the Bunsen burner underneath it, so it's still gaining heat or energy. It's just not changing temperature. So what's happening? Well, it's melting. All right. As it gains energy, it's going through this process, and it's changing state. The other one is up here, and that's when it gets to 100 degrees Celsius. It still has the Bunsen burner underneath it. It's just not going to get any hotter. What's happening is, again, it's changing state, and this is the vaporization. Up here is where it's getting every 2,260 joules of energy. A gram turns from liquid water into gas vapor. Alright, let's do an example of this. How much heat is required to melt 300 grams of ice at 0 degrees Celsius? Well, on here, we know that there has a mass of 300 grams. And it's going to melt. So that talks about the fusion. I'm going to use my equation of H equals M L F of W, the fusion of water. And I'm just simply going to plug and chug. At this point, the heat that's going to be required is equal to the mass, which is 300 grams, times that specific heat of 335. And when we multiply those, we get 100,500 joules of heat was required to melt this 300 grams of ice. For our second problem down here, I'm going to give this one to you to do. I will say that the first thing you're going to have to do is find out how much energy does the water have to melt the ice. And once you find out how much energy there is, then you can use that to find out how much ice indeed it will melt. I'll give you a second to do that. Well, I've gone ahead and filled some information in here for you. There was 350 grams. Specific heat of water is 4.19, and the water could go all the way down. Had an 18-degree temperature change it could experience before it would stop melting the ice. So at this point, I multiplied all those and find out that there was 26,397 joules of heat energy there to melt this ice. So I'm going to say that 26,397 equals the mass. Well, I don't know how much mass there is yet of the water, but I do know that the fusion of water is 335 joules per gram. So I take that 26,397 and divide it by 335 and found out that there is a mass that could be melted of 78.8 grams of ice can be melted from that. Well, I hope that helps you understand latent heat. Several of you had asked a few questions about it. But remember, specific heat is when it's changing temperature. Latent heat is when it's changing state. I'll see you tomorrow.